In 1346, there was a small epidemic that began somewhere in the probably Kazakhstan, Kyrgyzstan, and it spread into a full-scale pandemic that's known as the Black Death. So 1346, this massive epidemic spreads across Europe and ends up killing between 30 and 50% of the population of Europe, part of the Middle East, and into Africa. So it's the single most devastating epidemic in human history that we know of. We've been studying the genetics of the pathogen that caused this epidemic, Yersinia pestis, which is the causative agent of bubonic plague. But really something that we've missed or haven't been able to study carefully is what about the genetics of the humans that actually survived and those that perished? And so we thought, well, okay, you have 50 million people dying, 50% of the European population. There must have been genes in there that allowed certain people to survive and others, unfortunately, to succumb. And so you can only really study that kind of analysis in close proximity around the event that occurs. And so what we've done is we've taken 7 years to sample individuals right before the Black Death hit England, during the Black Death, and then right after. And we said, are there differences in their genetic makeup that might suggest some preponderance for susceptibility or for protectiveness? And there's a really interesting reason for that, because it turns out that the genes that did protect you against plague during the Black Death have an increased susceptibility for autoimmune disorders today. Just imagine a pair of scissors being the protein that's, comes from this gene, snipping these little pieces of the invading agent into little tiny pieces. The more pieces of different kinds you can get on your cell, the better your immune response will be. And during the Black Death, what we see is people that had two effective copies, one from mom, one from dad, that were really good at chopping up plague and putting on the cells, those people survived. It turns out that one of those genes can be defective. So now you only have one scissor, which means you have half the ability to cut the invading pathogen into little tiny pieces. So the more scissors, the more actively you cut, the better your response, the more likelihood you survive. And so knowing what those slight changes in individuals that allowed them to be increasingly susceptible and therefore die, that's an important part of not only just evolutionary theory, but how we prepare for better medicines and therapeutics in the future.